Hello futurists! Welcome to my YouTube channel where I track the acceleration of intelligence that will inevitably help us build a brain. In today's video, we'll be looking at AI and its relation to the gaming world. Artificial intelligence is a term that has a strong link to gamification. AI is a branch of computer science that focuses on creating programs and robots with human-like skills. Computer programs that learn from experience via repetition, by identifying objects and patterns, interpreting language, and making judgments based on those observations to solve problems, are known as popular AI. Despite the fact that we are still a long way from AI that is equivalent to human intellect, these solutions have become a part of our daily life. For example, AI advancements have made it possible for machines to collect and interpret data more precisely and quicker than people. In barely half a century, the fast growth of computer technology has revolutionized the world as we know it. But progress does not end there. Computer technology continues to advance at breakneck speed. Gamification and artificial intelligence, AI, have been around for a while, but the potential to combine the two is just around the corner. Yes, creating the appropriate machine learning models for these activities is difficult, but the tech community is actively working on new solutions. It's not about developing new technologies. Rather, it's about integrating two that already exist to achieve greater outcomes. This video's chapters are: Chapter 1. Ready Player Algorithm, AI in Board Games. Chapter 2. Understanding how AI works through gamification concepts. Chapter 3. The future of AI in video games. Let's get right into it. Chapter 1. Ready Player Algorithm, AI in Board Games. The idea that because AI systems can perform incredible feats of computation, they must be smarter and more objective than their flawed human creators is central to many standard AI accounts. Since the beginning of the discipline, artificial intelligence and board games like chess or Go have always been related. They do, in fact, provide a fertile field for evaluating the many AI methodologies and algorithms that have been created. AI research was in full swing when the first video games were released. As a result, it's understandable that attention has been drawn to this new medium. Consider this example of AlphaGo Zero, a Google DeepMind AI program that plays strategy games. It learned to play Go, a Chinese strategy game, by analyzing over 1,000 different options per move. Starting from scratch, our new program, AlphaGo Zero, achieved superhuman performance, end quote, the authors write in the paper announcing the breakthrough. Demis Hassabis, a co-founder of DeepMind, has compared these game engines to an alien intelligence. It doesn't play like a human, but it also doesn't play like computer engines. It plays in a third, almost alien way. It's like chess from another dimension. Hassabis described the next iteration's mastery of Go in 3 days as rediscovering 3,000 years of human knowledge in 72 hours. Since we're discussing the link between AI and gamification, we'll start with the source: video games. More specifically, we'll look at the case of OpenAI, an artificial intelligence program created for the Dota 2 strategy game. Yes, we've seen computer programs defeat world champion chess players. This type of game, on the other hand, lacks the many variables and complexities that would demonstrate AI's true power. In Dota 2, OpenAI plays the role of a game player. To learn about Dota 2, this general-purpose machine learning program played over 10,000 games against itself. The program has learned to play the game with all of its game mechanics, including different heroes, experience, levels, talents, spells, items, map mechanics, movements, and so on, as a result of this repetition. The program learned so much about the game after only 10,000 hours of play that it was able to defeat the best Dota 2 professional players in 1v1 matches. Keep in mind that Dota 2 is a complex strategy game with a colossal number of variables. Nonetheless, this machine learning system outperformed humans in terms of using mechanics. Alan Turing was the first to reveal a program capable of playing a full game of chess constructed on paper in 1951. In the future years, there will be more consistent developments. During this time, new chess games and chess engines were invented. These AI chess engines, on the other hand, were yet to find success on a higher level. It's possible that this is due to a scarcity of effective resources and tools. Garry Kasparov, the then world champion, stated emphatically in the 1980s that AI chess engines will never be able to overcome top-level grandmasters. For a few years, his prediction held true as he successfully defended his throne in 1996 against IBM's DeepMind in a 6-game tournament that concluded 4-2. He had already defeated Deep Blue's predecessor, IBM's computer Deep Thought, in a 1989 battle. Deep Blue resurrected a year after losing to the world champion to defeat him. In the rematch, Kasparov was trounced 2.5 to 3.5 by Deep Blue. Although there is some debate over the legitimacy of this victory, it is generally viewed in the chess engine's favour. In one of his recent interviews, Kasparov acknowledged that he had been defeated fairly and squarely. From the 1950s to the present generation of chess games, chess engines have come a long way. Many different types of concepts are used in the artificial intelligence systems built for human play. While it's difficult to say what each engine employs for its functionality and operation, we do know that neural networks, deep learning, and neural net-type automation are used by a few popular engines like AlphaZero. Leela Chess Zero is based on an open-source version of AlphaZero, a chess learning program that employs self-play games and deep reinforcement learning. Modern chess engines have advanced to the point where they will not lose a single game to human players. In a span of 100 games, even the current defending world champion failed to beat the modern greatest chess engine even once. Across all formats, the world champion has an FIDE rating of over 2,800. The competition is normally held in traditional time. Stockfish 9 was the opponent. It has a 3,438 rating. The engine ratings are not FIDE ratings, but the player pool for engines is much stronger than for humans. So theoretically, a FIDE rating for Stockfish 9 would be even higher. The scores of two recent chess engine battles are as follows. In a 100-game match, AlphaZero, a neural net-based digital automaton, defeats Stockfish 28-0 with 72 draws. Leela Chess Zero wins the TCEC Season 15 title with a 53.5 to 46.5 victory over Stockfish in a 100-game competition. These modern achievements, which have been achieved with the help of chess engines, neural networks, and deep learning-based chess networks, are a big sign of the ability for more and enormous opportunities. Chapter 2. Understanding how AI works through gamification concepts. First, let's begin with defining the term gamification. Gamification is the process of incorporating game components into non-gaming fields. This concept takes advantage of a person's innate competitive and collaborative impulses by establishing a reward system for completing a set of tasks. Gamification is really beneficial since it increases user engagement. It makes jobs that are often considered difficult more enjoyable and, as a result, simpler. Gamification can also be viewed as a collection of rules and processes for using gaming principles to solve issues. It's not that this strong instrument is new, it's simply that we didn't give it a name until lately. It's been utilized in education for ages, for example by awarding students various points and trinkets to demonstrate success. The Boy Scouts, for example, have long featured badges to demonstrate their members' accomplishments. Badges are also used to identify members who excel in specific activities. Gamification, in a similar vein, employs gaming principles to push people to behave in a specific way. For gamification, we may employ hundreds of different game concepts. Here are a few of the most well-known ones to give you an idea of how they operate. Badges. Players get badges when they complete a task or earn a certain number of points. These badges signify a player's accomplishment and encourage positive conduct. Game points. In gamification, points are the primary measuring units. Each LinkedIn connection, for example, is worth 1 point. Scoreboards, sometimes known as leaderboards, combine badges and points. Players may examine how they compare to one another and obtain a drive to improve. Originally, game-playing machines employed a combination of brute force reasoning, tree search, successful plays made by professionals in response to specific board positions, and other handcrafted expedients, including previous versions of the AlphaGo series. AlphaZero, on the other hand, relies only on the empirical outcomes of self-play. The starting point is a randomly initialized, deep neural network, an artificial neural network with numerous hidden layers that develops over time by playing against itself millions of times using just game rules and reinforcement learning. In the corporate world, artificial intelligence and gamification are becoming increasingly popular. Gamification is used by businesses to enhance performance and keep employees interested in a variety of operations. They deploy AI solutions, on the other hand, to allow their staff more time to focus on core duties and provide automation tools. Combining these two techniques also can produce some remarkable outcomes. AI and gamification may come together in a variety of ways. I've used Dota 2 and OpenAI as an example before. In this case, the AI operates within a gamification environment and exploits the game's mechanics to improve. Simply explained, gamification mechanics are employed to boost AI in this case. AI, on the other hand, may be utilized to generate the optimal gamification methods for a certain activity. It might evaluate outcomes depending on data input and utilize that information to develop new factors to better gamification outcomes. Chapter 3: The Future of AI in Video Games. It's clear from the first few results in a Google search for artificial intelligence in video games that in video games, artificial intelligence is frequently unsatisfying. As a player, you're also likely to come into circumstances when the AI's conduct just doesn't make any sense during gameplay. Why does AI in video games appear to be stagnating while the rest of the game, like its graphics, intricacy, and gameplay, continue to improve? While more and more AIs are able to compete with humans in board games like chess and Go, as well as strategic games like Dota 2, why do they appear to be trapped in the background or repeat the same stupid tirades while we play? The director of Sony, Kenichiro Yoshida, announced a future large-scale project. With the help of developers at its PlayStation subsidiary, he said they were going to create video game characters using artificial intelligence. Establishing a real interaction between them and the player thanks to artificial intelligence is Sony's new challenge. Instead of linear, pre-written storylines, these characters could adapt to the choices or behavior of the player's hero, and, through a process of trial and error, become an ally or an enemy. By their reactions and their behavior, they would then resemble real human beings. In fact, this is only one example among many of the incredible innovations that artificial intelligence allows in the video game industry. Over the past 10 years, the arrival of ever more efficient consoles and the evolution of technologies has already enabled many advances. Open worlds, complex quests, intelligent NPCs or non-player characters, and increasingly realistic graphics have thus made an appearance in modern games. However, with players increasingly demanding and looking for ever more immersive experiences, developers have decided to rely on artificial intelligence to create worlds and stories that live up to their expectations. If at the base, researchers used games to test the intelligence of their AI, In recent years, we have seen the opposite phenomenon. Technology is now at the service of the video game industry. Ubisoft studios have bet on artificial intelligence in their game Watch Dogs Legion. While strolling through the city, the hero meets many people who will adapt to their different interactions with him until they change their behavior or their daily habits. Other games have preferred to create enemies capable of remembering previous fights, as allowed, for example, by the Nemesis system developed by Monolith Studios, which unfortunately still remains underused in modern video games. Electronic Arts, meanwhile, is currently looking into a technology that would allow the use of machine learning to reproduce or mimic body movements or facial expressions from video or photo material. This project also resembles this AI that has been honoured thanks to the Deep Nostalgia application by animating the faces on old photographs. This similar innovation from Electronic Arts would thus make it possible to find an alternative to motion capture, which is currently expensive and time-consuming. Eventually, this will allow players to create an avatar in their image. They will be able to record their facial expressions using a simple webcam. Mods, modification of the game by an outside person, have always been very popular, especially on PC games, which even encourage their development for some. Indeed, they can totally change the look or the narrative of a video game. A modder recently released an update to The Witcher 3 with no more and no less than the voice actor playing Geralt of Rivia declaring new lines of dialogue. This one used an artificial intelligence to reproduce the exact intonations of the hero, creating a perfect imitation. This news sent cold sweats to the voice actors, who expressed their fear of seeing their profession disappear in the face of the arrival of these new technologies. For the moment, there is no indication that the technique tends to become widespread, but there is no doubt that with recent advances, it will be more widely used in the future, if only during the preliminary stages of development. It is now possible that artificial intelligence can now create its own games. After scenarios or press articles created by AI, it was the video game industry that decided to exploit the creative potential of this technology. The first game created in this way is called Candy Shop Slaughter, and it is certainly quite basic, but it has all the elements required to make it a successful mobile game. The reception was also very positive, and the players showed a certain enthusiasm for the scenario, the gameplay, and the characters offered. This first successful experience marks a real turning point in the world of video games, and there is no doubt that artificial intelligence will continue to prevail in the coming years, whether to modernize old games or to offer ever more breathtaking and immersive entertainment. Thank you for watching. If you enjoyed the video, hit like, and if you want more content like this, subscribe to the channel. Make today a great day. Until next time, keep thinking.